Let us now look at how we measure productivity. We know productivity means outputs divided by inputs. In other words, how much output can I produce for every unit of input that I consume? A very commonly used productivity measure that we are all familiar with is miles per gallon. Similarly, if you're thinking about a light bulb, you can measure its productivity in terms of lumens per watt. In other words, how many lumens of light does it produce for every watt of electricity that is consumed? Similarly, if you're conducting a customer service process, you can think about how many customers were served for every employee that was hired. Or if you're thinking about a retail store, you can think about how many dollars of sales revenue did you generate for every square foot of the store area. Another productivity measure that we may all be familiar with is return on investment. Basically, we are measuring for every dollar of investment, how many dollars were returned. The reason we are concerned with productivity is because we are always trying to do more with less and trying to get the job done with a smaller budget. Let us say I was shopping for a light bulb. I'm looking for a traditional incandescent light bulb that uses 100 watts of electricity. Meanwhile, I run into you and you look at me with a weird look and ask me, Professor, why don't you buy this CFL bulb? And you pick up one and show it to me and it looks like a pretzel. It's all twisty. And I say, what's so special about this bulb? That's when you explain to me that the traditional light bulb produces 1600 lumens of light. The CFL light bulb also produces 1600 lumens of light. The big difference, of course, is that the CFL bulb consumes only 25 watts of electricity. So I'm really intrigued by this. I immediately take out my calculator and I start calculating the productivity. You can see that the productivity of the traditional light bulb is outputs divided by inputs, which is 1600 lumens divided by 100 watts. So that comes to 16 lumens for every watt of electricity that goes in. Doing the same calculation for the CFL bulb, we divide 1600 by 25, and that brings us to 64 lumens per watt. You can see that the CFL bulb beats the traditional light bulb hands down when it comes to productivity. So I'm really impressed by this, and I go down the aisle looking for a CFL light bulb. And that's when it hits me. The price tag on the traditional light bulb says $1, but the price tag on the CFL light bulb is $5. So once again, I start doing some productivity calculations, and now I have output divided by input equals 1600 lumens for every dollar of investment. Doing that for the CFL bulb, I get 320 lumens for every dollar of investment. Now you can see that the traditional light bulb is much better than the CFL bulb. And that is how it is typically with productivity measurements. If you use one measure of productivity, this process ends up looking better. If you use another measure of productivity, the other process ends up looking better. Now, how about if I try to combine these to come up with some sort of a holistic productivity measure? I know that the traditional light bulb consumes 100 watts of electricity, and it also requires $1 of investment. The CFL bulb consumes 25 watts of electricity and requires $5 of investment. If I add these up and come up with what is called a multi-factor productivity measure, I can now calculate output divided by input, which equals 1600 lumens divided by 100 watts plus $1. Now you can see I run into a problem over here trying to add watts and dollars. Now the only way I can add two different kinds of inputs over here, electricity and investment, is if I can somehow convert them both to the same units. That's often easy in a business process because most things can be converted to dollars and cents. So if I somehow convert the 100 watts to dollars, and the investment is already in dollars, so I can add up these and I can come up with a productivity measure that tells me how many lumens of light do I produce for every dollar of input. Now we have to keep in mind that the dollars for the electricity and the dollars for the investment are over the same period of time. Again, I can do the similar calculation for the CFL bulb, and I can compare these two processes and I see which one is better overall. As we have just seen, we can calculate productivity based on different kinds of inputs that are going into a process, and each of these we call as a single factor productivity measure. Now, typically, we can think about productivity measures such as labor productivity. Labor is a very important input that goes into any process. Likewise, we can think about capital or equipment productivity. Again, capital or equipment is another kind of input that goes into a process. Likewise, we can also think about raw material productivity. As we have just seen, whenever we have single factor productivity measures, there are likely to be trade-offs. One of them is high, the other one is low. One of them points us towards process A, the other one points us towards process B. Typically, we also need multi-factor productivity measures, which give us a sense of overall how are we doing with respect to multiple factors of input. Now, of course, if we can throw in every single possible factor of input, then we are talking about total productivity. Now, let us say, for instance, you are a manager of a process that is producing some bottles. The process output here is the number of bottles produced and sold, and the inputs that you consume are labor, equipment, and raw materials. Let's say in week one, you produced 1,000 bottles and you sold them at $20 each. So your output over here was $20,000. And to produce this output, let's say you consumed X dollars worth of inputs. Now, when you went to week two, once again, you produced 1,000 bottles. However, market conditions had changed, and so you were only able to sell them at $15 a piece. So now your output has reduced to $15,000. So what we find here is that output has decreased by 25%, while input has remained the same, so productivity has decreased by 25%. Of course, your boss is going to call you up and ask you, what happened? Why did productivity go down? And that's when you give every possible excuse to say it was not your fault. In this case, clearly the facts bear you out. You consumed X dollars of input and produced 1,000 bottles in week one, and you did the same thing in week two. So the productivity of your process itself was the same. What had changed were market factors, and those market factors were not under your control. And therefore, if you assess the productivity of this process based on factors over which this process has no control, then you will be getting an incorrect measure of productivity. Typically, the lower the level of the unit that you're trying to assess in an organization, the more limited the set of factors over which that unit has authority. So in that case, you want to measure productivity only with regard to those inputs over which the unit has control. And you're talking about maybe single factor productivity measures and multi-factor productivity measures to the extent they make sense. But as you travel higher in the organization, and the larger the unit you are assessing, the unit now has responsibility for a larger set of factors. You need more overarching measures, such as multi-factor productivity measures or total productivity measures. And as you go to the highest point in an organization, pretty much all you're looking for is return on investment, return on assets, return on equity, and you're simply asking the question, I put in $1 of investment, how many dollars came out? Of course, even at that point, you still want to have a dashboard of every kind of measure possible, because you want to know this measure went down, that measure went up, but what you're interested in is overall, for every dollar that I put in, how many dollars came out.